Hi guys, this video here is to help you guys do section 2.2a, b, and c with a calculator instead of using table A on your formula sheet. Okay, so we're going to start off right away with the questions that say what percent. When it says what percent, I want to remind you, or it could say what proportion, probability, either of these. It's all the same process. When the question reads what percent, what's the probability, what proportion, we do the same thing every single time. First, 1, we draw the picture. We mark our mu, we mark our observation, we mark our standard deviation, and we shade. 2, we find a z-score. 3, instead of going to table A, we can go to the calculator, and that's what I'm going to show you right now. If you don't have a graphing calculator, I want to show you how you can get one. You just go to Google, okay? You type in MCA calculator, Minnesota standalone calculators. Go to grade 8 and 11 graphing calculator. Start, and then go up to where it says calculator right here, and it will give you the TI-84. Okay, so with that being said, let's go back to our Smart Notes. I'm going to work with just the grain right now. And what this reads, if you're not familiar with this, it reads, what is the probability, or what is the proportion, or what is the percent? Okay, that P you can read anyway. Technically, it's probability. Okay, but we're trying to find the area under the curve with this upper bound here at z equals 1.23. So let me walk you through the picture. Draw a picture. I drew my picture. I don't know my mu. I don't know my standard deviation. And what I'm telling you right now that z is 1.23. What this sign here means we have a less than problem. We want to know the probability or the percent of the time that our z will be less than 1.23. So what I've already done is I've taken out of the picture the observation, the mean, and the standard deviation. And you don't need to do ZOMs. You don't need to find the z-score. I've already given you that z-score. For those of you who are struggling on 2.2a, hopefully that helps. This means I'm finding the z or the percentage or the area behind this line here at z equals 1.23. Typically we go to the table to find that, but now I'm going to show you how to use the calculator. Okay? Okay, so to go to the calculator, what I'm going to do is I am going to hit second vars. I am going to go to normal CDF. And I'm going to have a lower bound. Now, how do I know what my lower bound is? And I'm going to summarize this all for you here at the end. But whenever you're doing a less than problem, your lower bound is going to be negative 999. This is your lower bound. So we read left to right, lower bound to upper bound. Okay? So in my calculator, I put negative 999. My upper bound is the z-score, and our z-score was 1.23. Okay? Now, one thing you need to know, don't ever mess with the mu or the standard deviation. There's a reason for that, is I want you always to be finding the z-score. I don't want you to put in what the mean and the standard deviation is. Always leave mu as 0, and the standard deviation is 1. Your lower bound and upper bound will change, but you'll be using 9999 and your z-scores. Okay, I'm going to hit paste. If you have the old calculator, you don't have that, here's what it will look like. You're still going to go to normal CDF. Your first number will be that negative 999. That stands for the lower bound. You're going to put the comma, which is right here. The next number you put is the upper bound. That's our z-score, 1.23. You're going to put a comma again. 0 stands for your mean. 1 stands for your standard deviation. We're going to hit enter. And you can see the area behind that curve or behind that upper bound is 0.89065 or 0.8907. So on 2.2a, when it looks like this, you would just say that the answer is 0.8907. I'm not going to write it down just to keep this video hopefully a little shorter. I'm already taking a little bit more time than I'd like. Okay, the next one I have for you is a greater than problem. Whoa. We have the probability that z is greater than 2.67. I'm really wondering, what percent of observations are going to be greater than a certain number. right? That's what the question's going to ask. And look at the purple now. I don't want to mess you up. Oh, I'm trying to get it to move here. Sorry, guys. Okay. So this is a greater than problem. So you pretend, hey, we have our picture, we have our mu. It doesn't matter what our mu is right now, but you would always mark it. We have our standard deviation, which is sigma. We had an observation right here, and then we found the z-score that went with it. We shaded to the right because we're wondering the percent that goes when z is greater than 2.67. Now at this point, we would go to our table normally on step 3. We'd go to 2.67 on the outside and find the decimal. Then what we would have to do is subtract from 1. Why? Because our table only shows the less than problem. So what am I going to do though with the calculator? Now because it's a greater than problem, we approach it just a little bit different. We go to second vars. We go to normal CDF again. Now our lower bound is right here. Okay, remember we always read left to right. This is our lower bound right now, 2.67. Oops, my number. Sorry, not working. 2.67. And then we have our upper bound. Now our upper bound is going to be 9999 on this side. Okay, 3 9 suffices. I don't know how many I just said. I have a little bit of a cold, so forgive me. And now we're going to hit paste. Again, for those of you with the older calculator, you just type in your lower bound here, comma, your upper bound, 0, 1, always. We're going to go through, and we're going to hit enter. This is going to give you the area to the right of that upper bound, okay? This is that area in there, and we can change it to a percentage or we can leave it to a proportion. I don't really care. If it says what percent and you leave it as a proportion, meaning a decimal, I'm fine with that. Okay, so we have 0.0038, and that would be our answer for a greater than problem. This one's an in-between problem, right? Okay, again, we draw our picture, we have our mu, we have our standard deviation. Typically, we would have 2 observations in the problem. It would say, what is the probability, or what percent of the time would we be between these 2 observations? We change both these observations to z-scores. I gave you the z-scores. This is reading the probability that z is going to be between negative 1.25 and 2.45. Or what percent of the time will z be between negative 1.25 and 2.45 in a normal distribution? Again, let's go to our calculator. Second, vars, normal CDF. Our lower bound this time is right here, this line, negative 1.25. Our upper bound is that upper z-score, so 2.45. Again, leave it as 0 and 1. Oops, I did something wrong here. Oh, you know what I did is I did a minus instead of a negative. So I'm going to change that. Hopefully that works there for us. All right, I got to go back. No big deal. Let's go to second vars, normal CDF. And I'm going to put a negative there, 1.25. All right, that should do it. And there we go. We have 0.6345. So what percent of the time will our observations be between an observation where we have a z-score of negative 1.25 and a z-score of 2.45? The proportion of the time is 0.6345. The percent of the time would be 63.45% of the time. Again, I don't care. Now let's talk about going backwards, what we did today. When you have a going backwards problem, I'm sorry, I'm getting a little overly, I'm going over with the click, forgive me. When we have a going backwards problem, I'll type it over here. First thing we do, again, draw a picture. Okay, now what I want to do is I want to know what z-score goes with the 88th percentile. So I draw my picture, my mu in the center, my standard deviation, and then I don't know this observation, right? So I'm going to just, when we're going backwards, when you are given a percent, you're just writing OBS for observation or X or whatever letter they give you. Now a percentile is always less than by definition. So I write my bound, I go less than. 88%, if you're curious, how did I know it's on the right-hand side? This area right here, this point at the very end of the curve, that's 0%. 50%, 100%. So 88% would be somewhere over here. I'm going to the left by definition. Now what you would do on your table is you'd go to 0.88 in the inside and go out and find the z-score that goes with it. Okay, we're going to the calculator now. And with the calculator, we're going to use something called inverse norm. Let me show you how to use that. Go to second vars. Inverse norm is number 3. Hit enter. The area now behind the curve is 0.88. Always leave it at 0 and 1. And now paste. I have 1.17. That is the z-score now. 1.17 is the z-score that goes with the 88th percentile. Now, if I knew the mu and the standard deviation, what I would do from there is I would plug it into XOMS and use algebra to solve for x. I don't have that information. You don't have that on 2.2a, so you don't need to worry about that at this point. I'm just trying to show you how to use the calculator. Now, the top 10%. Again, I'm going to draw my picture. My mu, my standard deviation. The top 10%, I accidentally put 0.01. It should be 0.10. Forgive me. Let's see if I can draw it with. Okay. The top 10% is over here to the right. Okay. If I'm in the top 10%, that means I'm in the percentile is the 90th percentile. Okay. Remember, percentile always means less than. So this area all here is the 90th percentile. Percentile is always less than, so I'm just trying to sketch it for you right here. Okay, I want to know what observation will put me in the top 10 percentile, which means I am in the 90th percent. Okay, our calculator right now, or at least the one I have, only does less than as well. I'm going to go to second vars. I'm going to inverse norm. I'm putting 0.9 because I'm in the 90th percentile. That gives me the top 10%. Mu is equal to 0, standard deviation is 1, and I'm going to paste. And I get 1.28 is my z-score. Okay. Oops. Oh, I have too many things open. Z is equal to 1.28. So a z-score of 1.28 will put my observation in the top 10th percentile. Okay, or the same thing would be the 90th percentile. All right. All right, if you have any questions, please write them down. Hopefully this helped for the calculator use, and please get used to using that graphing calculator. Even if you don't own one, you all have a Chromebook and hopefully internet access. If you don't, talk to me, but you can use this MCA TI-84 and get used to the graphing calculator for the tests and especially that AP test. Have a great election day tomorrow, everyone. Take care.